Here's part 2 of Keeping It Fresh, Chapter 5. We're on page 2, looking at question number 13, and this is taken from obviously Chapter 5. We want to write the unit rate, okay, so 1, that represents the situation. Well, 18 touchdowns in 6 games, okay, we're wanting to get the unit rate, so it would be how many in one game. Well, just like with the equivalent fractions, how do we go from 6 games to 1 game? We have to divide by 6, so whatever we do to the denominator, we need to do to the numerator to keep it equivalent. 18 divided by 6 would be, you're scoring 3 touchdowns per game is the unit rate. 3 touchdowns per game. If you are able to send 35 text messages in 5 minutes, we want to know the unit rate, so not in 5 minutes, but what about 1 minute? Well, how do we go from 5 minutes to 1 minute? We divide by 5, so whatever we do to the denominator, we need to do the numerator. 35 divided by 5 would be 7. You are sending 7 text messages, I'll abbreviate, per minute. You guys can probably do that in your sleep with one hand tied behind your back and your eyes closed. Okay, which obviously if you're sleeping, your eyes are closed, but yeah, you get the point. 7 text messages per minute is the unit rate. Okay, for number 15 here, see if you can complete the table. So fractions, decimals, and percents, they're all equivalent to one another. Looking at this top one, I see 45%. Well, I know percent means out of 100. Okay, so if I wanted to, I could jump back over here. 45 out of 100. But then let's put that in, in simplest form. They both end in 5 and 0, so thinking of my divisibility rules, I could divide by 5. 45 divided by 5 equals 9, and 100 divided by 5 equals 20. So 9/20 is in simplest form. Okay? When we're making a decimal, I'm going to use the out of 100 because in our decimal place value, there's tenths, hundredths. And if I need 45 hundredths, I could just fill that in. And I want a number in front of the decimal, so I have 0 and 45 hundredths, which matches the fraction, which matches the percent. Okay? Here's our decimal. I like to go fractions, so I see it's tenths, hundredths. There's 17 hundredths. And 17 is a prime number, so I know it's in simplest form. It can't be divided. And then since it's 17 out of 100, I could write that as 17%. Here we have the fraction 3/10. Okay, so yes, I could write that as a decimal. Tenths, 3/10. I'm done. There it is. Now some people are going to make the mistake and say this is 3%, 3 out of 100, but this is 3 out of 10. So I need to make it out of 100. How do I go from 10 to 100? Times 10. If I do that in the denominator, I need to do that on the numerator. 3 times 10 is 30. These are equivalent fractions, and the reason I needed to get it out of 100 so I could write it as a percent. 3 out of 10, if you scored on a quiz or test, that means you got a 30%. Okay? Chapter 6, using less than, greater than, or equal to. Negative 19 compared to negative 5. Alligator is going to be going towards negative 5 because that is farther to the right on a number line. The absolute value is always 4. It's the distance between 0 and negative 4, and that would be 4 units. 4 compared to negative 2, I know the alligator would be going to the 4. 4 is greater than negative 2. The absolute value of negative 9 is always positive, so 9 compared to 9, those are equal to one another. Number 19, I have negative 2/3 and negative 3/5. Well, with unlike denominators, I can't really compare them. Okay, and I see they're probably going to be close, so I need to find a common denominator. Well, 3 and 5 both have a common multiple of 15. So 3 times 5 is 15, so 2 times 5 is 10, and I know that's negative. And then to get 5 to 15, I have to multiply it by 3. 5 times 3 equals 15, so 3 times 3 equals 9, and that's negative. Okay, so if I'm in a hurry, I'm going to think, oh, 10/15 is greater, but actually since it's negative, I know that 9/15 or negative 9/15 or negative 3/5 is greater because that is farther to the right. And lastly, or for the inequality part, 18 and 17 hundredths compared to 18 and 3/10. Okay, so a lot of people are going to think 17 is bigger than 3, but actually remember if we line them up, if we're not in too big of a hurry, I know that the 18s are even, but I know that 3/10 or 0.3 is bigger than 0.1. So the alligator will be going to the right, less than. Chapter 7, Tell whether the ordered pair is a solution of the equation. Well, I see here's the ordered pair. I know it's always x and then y. I know my ABCs. It always goes in that order. And I could substitute it, and so instead of y, I'm writing 7 equals 3. Instead of x, I can do 2 plus 1. Order of operations, I'm going to multiply first. And does 7 equal 7? Yes. How about for 22? I know it's always x, then y. Make my substitutions. Take out y, we're putting in 22. Bringing everything else down and taking out x, I'm putting in 4. Bringing everything else down. Okay, I'm going to do my multiplication first. Bring everything else down. 28 minus 24 is 24. Does 22 equal 24? No. No. Okay? Write the word sentence as an equation. Since it's telling me to write it as an equation, I know I need an equal sign. Not an inequality sign, but an equal sign. So when they say less than, they're not talking about the alligator, they're talking about subtracting. 6 less than a number t is 7. If you need 6 less of something, that means you need to take away 6. So our equation would be t take away 6 is equal 7. 6 less than a number, so I need 6 less than t, I'm taking away 6. And then a number m increased by 5, increase is telling me to add, so m increasing it by 5 is equals 18. Alright, and then the last page, going a little quicker here. Write the word sentence as an inequality, so I'm paying attention to my directions now. So no longer I'm thinking an equal sign, that's an equation. Now I'm thinking inequality. So it's alligator, crocodile, Pac-Man. And we have the product of 8 and m is less than 5. So the product of 8 and m, so those are going together, so we have 8m, we're multiplying, is less than, reading left to right, less than 5. And 26, the number h plus 5, there's a nice friendly one for us, h plus 5 is at least negative 12. Okay, if you ask mom or dad for at least $10, you're hoping that they give you $10, or really you're hoping for anything more than $10. So when they say at least negative 12, we're thinking greater than or equal to negative 12, because we want that much or more, at least that much. Graph the inequality on a number line. That's missing, but you guys get the point. Number 27, m is greater than or equal to 5. So when we're just graphing here, there's no solving, okay? It's just graphing this. I'll go 2 intervals each way. My circle's going on the 5. I'm asking myself, is it open or closed? Because it's equal to, I know this is a solution, so we're filling it in. And then we want the numbers that are greater than or equal to 5. So greater than, we're going to the right. Number 28, x is less than negative 13. So negative 13, negative 12, negative 11. Thinking of my number line, we're getting closer to 0 going to the right, and we're getting farther from 0 going to the left. My circle's going on 13. Do I want it filled in? No, because it is not equal to. Negative 13 is not a solution. And then we want the numbers x is less than negative 13. So what numbers are less than? We're going to the left. Okay. 29. 4 is less than or equal to r. So we have 4, 5, 6, 3, 2. Smaller to larger going to the right. Now I'm okay with some of you if you know 4 is less than or equal to r. So 4 is less than or equal to, so I know that 4 is a solution. I can fill that in, but now which way do I want to go? Okay, well 4 is less than the r's. So that means this is less than the r's. That means the r's need to be over here. Okay, or what I would recommend to you is to flip these around. You get in the habit or the comfort level of always having the variable on the left. So if I switch the r, I switch to 4. I also need to switch the inequality. So now I can think r is greater than or equal to 4. So what are numbers I can substitute in there for r that are greater than 4? Well, 5 is greater than 4, 6 is greater than 4, so I need to be going this way. And number 30, same thing. When I see this, I like to switch it. Get that variable on the left side, switch the variable, switch the 9, switch the inequality. The inequality is going towards 9. The inequality is going towards 9. So my circle's going on 9. I am not filling it in because it is not equal to, not a solution. Now we want W is less than 9. So ask yourself, what is less than 9? Well, 8 and 7 are less than 9, so I want to be graphing my solutions that way. Everything to the left of 9 is a solution. Chapter 11 are integer rules. Okay, we're adding, are they the same sign or different? Positive, negative, they're different, so we need to find the difference. The difference between 17 and 9 is 8. Now, what is farther away from 0, the positive or the negative? The positive is farther away from 0, so we're going to keep it positive. 32. Subtraction. Our rules are to change the subtraction to addition and change the sign. So keep, switch, flip. Okay, so change subtraction to addition, and we're changing the negative to positive. So now we have negative 4 plus 7. Addition rules, I see the signs are different because I have a negative and a positive, so I need to find the difference. The difference between 4 and 7 is 3. Which one is farther away from 0, the negative or the positive? The positive is farther away, so I know my answer is going to be positive. Another subtraction, change the subtraction to addition and then change the next sign. So negative 10 plus negative 6. Well, now our addition rules are we have the same sign, negative and negative, so we're going to add. 10 and 6 is 16. And when they're the same sign, we keep the sign or we use the sign. So negative 10 plus negative 6 would be negative 16. Almost there. Now we're multiplying. 5 and 9 is 45. And when the signs are the same, it's always positive. Okay, we were losing the negatives, so that means we have positives left. 4 times negative 7, well I know 4 and 7 is 28. And now the signs are different because we have a positive, negative. Signs are different. Product is negative. And then 108 divided by, negative 108 divided by negative 12. Well, I know 108 divided by 12 equals 9. And I see negative, negative, so the signs are the same. When the signs are the same, quotient is positive. All right, so there is Keeping It Fresh, Chapter 5.